This time, we will have solving quadratic equations or functions by factoring. Factoring is finding what to multiply together to get an expression. It is like splitting an expression into a multiplication of simpler expressions. We try to determine whether the given expression is factorable or not. First example, x squared plus 4x. The answer is factorable. Its factors are x and x plus 4. The type of factoring being used here is common monomial factor. Next example, we have x squared plus 3x plus 1. This expression is not factorable. Next, x squared minus 12x minus 28. This expression is factorable. Its factors are x minus 14 and x plus 2. Next, 4x squared plus 20x plus 25. This expression is factorable. Its factors are 2x plus 5 and 2x plus 5. Or we can simply write it as the square of the sum of 2x and 5. Another, 6x squared plus x minus 2. This expression is factorable. Its factors are 3x plus 2 and 2x minus 1. Next, x squared plus 4x plus 16. This expression is not factorable. Please try to recall the types of factoring for you to better understand this lesson. So here are the steps in solving quadratic functions by factoring. First, transform the equation into its standard form if necessary. Clear the equation of all fractions if there are. Remove the parentheses and combine like terms if there are. Second, change f of x, g of x, or h of x to 0. Third, get the factors. Fourth, equate each factor by 0. And fifth, solve for the roots, solutions, or zeros of the equations in step 4. Example, f of x is equal to x squared plus 7x. So we change f of x to 0. Our equation in its standard form is x squared plus 7x equals 0. X squared plus 7x can be factored. And we are going to use common monomial factor. Your common monomial factor is x. So we are going to factor out x. For the other factor, we have x squared divided by x, which is equal to x. Positive 7x divided by x is equal to positive 7, equals 0. Our next step is to equate each factor to 0. So x is equal to 0. And x plus 7 equals 0. We transpose positive 7 to the right side of the equation. X is now equal to negative 7. The zeros, roots, or solutions are 0 and negative 7. For our second example, we have f of x equals x squared minus 4. We change f of x to 0. So our equation is written as x squared minus 4 equals 0. The type of factoring to be used here is factoring the difference of two squares. So the factors are x plus 2 and x minus 2, which is equated to 0. We now equate each factor to 0. So we start with x plus 2. X plus 2 is equal to 0. We transpose positive 2 to the right side of the equation. So x is now equal to negative 2. We now equate the other factor to 0. So x minus 2 is equal to 0. We transpose negative 2 to the right side of the equation. So x is equal to positive 2. The zeros, roots, or solutions are negative 2 and positive 2. For our third example, let's have f of x equals x squared minus x minus 2. We change f of x to 0. So we have x squared minus x minus 2 equals 0. X squared minus x minus 2 is factorable. Its factors are x plus 1 and x minus 2 equals 0. We will now equate each factor to 0. We start with x plus 1. X plus 1 equals 0. We transpose positive 1 to the right side of the equation. So x is now equal to negative 1. Now we equate x minus 2 to 0. We transpose negative 2 to the right side of the equation. So x is equal to positive 2. The zeros, roots, or solutions are negative 1 and positive 2.